So hi guys! So today I'm going to be doing balancing equations. Now I know I went into biology, but now I'm coming back to chemistry to help out some of you people who have some trouble with balancing. So there's two types of main equations. There's the regular ones, right, which are the common ones that you find that are pretty easy to balance. Then you have the redox ones, which are similar, but there is a bit of a twist. Okay, so a lot of you guys probably recognize this equation, which is glucose plus oxygen gives you carbon dioxide and water. This is your equation for cellular respiration. Haha, biology and chemistry. Okay, so this is my first equation that I'm going to balance. So, the first thing you do is you write out your atoms for your products and your reactants. So first I'm going to do my reactants. Please don't mind the horrible writing. So on my reactant side, I have some carbons, some hydrogens, and some oxygens. Okay? And then on my product side, I have, once again, some carbons, oxygens, and hydrogens. Now this part is simple. You just have to count how many of each atom you have on either side of your equation. So on my reactant side, I have 6 carbons, so I'll just note that I have 6. For my oxygens, I have 6 plus 2, which is 8. Oops. For my hydrogens, I have 12 hydrogens. Simple, right? Okay, now you do the same thing for your products. So on this side, I have 1 carbon, 2 plus 1, which is 3 oxygens, and 2 hydrogens. Now, if you guys have taken biology, you probably already know what this balances out to be, but still I'll take you guys through the process. So first you look at your carbons. You always look at your first non-oxygen or hydrogen atoms. So in this case, since it's carbon, I see that I have 6 more carbons on my reactant side than I do on my product side, which means that I'd have to multiply this by 6 to balance off my carbons. Now look at my hydrogens, and I have 6 times as many on my reactant side than on my product side. So I have to multiply this one by 6 to get 12 hydrogens on either side. So now when I look back at my equation, first of all I need to balance my carbons, which I said was a 6, right? So this number changes to 6, which balances. You don't really have to look at the oxygens yet. Don't look at the hydrogens yet. Okay? Now you look at the total number of oxygens you have on your product side since that number changed. So what you do is, since you have 2 oxygens from your CO2 originally, but I now have 6 carbon dioxides, I multiply the 2 by 6, and that gives me 12 oxygens on this side now, no longer 3, plus 1 for my water, which gives me a total of 13 oxygens, which is way more than 8. Now I look at my hydrogens. So I said that we needed to put a 6 in front of the hydrogens to balance them off. So this gets a 6 in front, which once again changes my oxygen count. There's 18 oxygens on this side now, which means that if I put a 6 in front of here, that'll give me 12 plus 6, which is 18, and that balances your equation. Now, so that means that my final equation for cellular respiration, if you haven't learned this yet in biology class, you can learn it now, is glucose, which is C6H12O6, plus 6 oxygens, which is just air, You never put in the nitrogen that's in the air because that's an inert gas and will just go right through you. And you get 6 carbon dioxides plus 6 waters. And this is why you have to inhale oxygen and you give off carbon dioxide. Okay, so the next equation is not going to be a normal equation. It's going to be one of my redox equations. Subscribe to me so you guys can see some cool videos doing science and experiments and maybe learning something new. Thanks!